When you have a progressive thread with AI where you go back and forth, it only remembers so much. So if the thread is very, very long, there's stuff at the beginning that it no longer remembers, and it
Mhm.
will come back and say the same thing to you again and again and again. So to address that, he's been exploring this concept of AI scaffolding. And the idea there is that you use AI and you collectively, you build up a document that acts as an input for the AI prompt. And because of the buffer problem, you start a session with an AI, you only go 2 or 3 prompts and then you end it. That session is ended, but everything that was there was documented in this document that is the input to the next interaction or session with the AI. And you do this progressively, and you end the session with the AI at some frequency,
Mhm.
but everything's documented in that document or spreadsheet or whatever you're going to use. And that way it always has the full context, because when you start a new session, it reads the whole document and says, okay, these are the constraints. This is the background information, and it can hold that. So I thought it was fascinating. Um, it's a fascinating approach to address an issue that we're experiencing with AI today and a way to make it more productive. So that's the top level view. Number one, I think this method could work. It can make things more productive right now, but there's going to have to be a culture shift in some engineering domains. Like, for example, system engineers can be fairly disciplined around, okay, let's get this stuff in the model. Because if it's
Mhm.
not in the model, then you can't do traceability, you can't do a flow down for RFLP. Um, So I think that could work well with systems engineers. Hmm. With mechanical engineers, it might there might be challenges. And we've talked about this before, where a mechanical engineer sees the space that their design needs to go into, right? A bracket, a motor, whatever it's going to be. They do a lot of that processing around constraints and context in their head. It never gets documented anywhere. And then they go into CAD and start creating 3D geometry. So they jump from no documentation or very, very little documentation to I'm developing the physical implementation of the solution.
Mhm.
So I think for a system engineer that might be very disciplined, this method could work really well. For a mechanical engineer that's used to, skipping steps, or as I like to say, show your work for calculus.
Yeah.
Um, it's a big change, and I think that could be an impediment or a barrier to adopting this approach.